power our world? I mean, really power it. It's one of the biggest questions of our time, and the answer is changing fast. Today, we're going to go on a journey from the fuels that literally built our modern civilization to some really radical ideas that might power our future. Let's dive in. Okay, just take a look at this. This chart right here lays out the challenge perfectly. Not that long ago, in 2010, a whopping 80.6% of all the energy we used on the entire planet came from fossil fuels. That means everything else, nuclear, solar, wind, you name it, was just a tiny sliver of the pie. This is our starting point, and it really sets the stage for one of the biggest transitions in human history. All right, so here's our game plan. First, we'll get a handle on our massive global energy diet. Then, we'll meet the three main contenders in the race to power our future. We're going to dive deep into the great debate between the two biggest low-carbon options, uncover the single biggest bottleneck that's holding renewables back, and finally, we'll get a glimpse of a future that might literally be paved with power. So first up, just how much energy are we even talking about here? It's so easy to take for granted, but our modern world runs on a truly colossal, nonstop flow of power. Just think about your day. The car you might have driven, the factory that built your phone, the heat in your home, the data centers bringing you this very explainer right now. It's all powered by energy. It is the engine of our lives, and that engine's appetite, it's only getting bigger.
So, if we have to shift away from that 80% chunk of fossil fuels, what are our options? Well, broadly speaking, the future of energy is a race between three major paths. So let's meet the contenders.
First, you've got the incumbent, fossil fuels. They're incredibly energy dense, all the infrastructure is already built, but they're non-renewable and they're the main driver of carbon emissions. Then we have nuclear fission, the powerful workhorse. It's a low-carbon, super potent source of energy, but, as we'll see, it's really controversial. And finally, you have the challengers, renewables. Sourced from the sun, the wind, and water, they're clean and they're growing at an incredible rate. But they have one major catch. They aren't always on. You see, because the goal for so many is to move away from fossil fuels, the real fight for our low-carbon future often boils down to this head-to-head matchup, the concentrated power of the atom versus the diffuse power of the elements. And the contrast here is pretty stark. On one hand, the promise of nuclear is huge. It's a low-carbon source that's already displaced something like 64 gigatons of CO2. And, believe it or not, some analyses show it's actually caused fewer fatalities per unit of energy than fossil fuels. But the peril? Well, the peril is just as stark. The risk of accidents, while super rare, is catastrophic. The upfront costs are enormous, and public opposition is a massive hurdle to overcome. And nothing, absolutely nothing, illustrates that peril more than this. The Fukushima disaster in 2011 was a profound shock to the entire global energy system. It forced 50,000 households from their homes and led countries like Germany to decide to shut down all of their reactors. It's just a powerful reminder of the risks involved, even if they are statistically low. And this brings us to the court of public opinion, where, wow, the difference could not be clearer. A global survey showed overwhelming support for renewables. Solar came in at a staggering 97% approval, and wind at 93%. And nuclear, it polls at just 38%. That social and political reality is a huge factor in how our energy future is going to get built. So let's flip the coin and look at the explosive growth of renewables. Hydro is kind of the quiet giant here, providing most of our renewable electricity today. But then you have wind power, which has been growing at 30% a year. And solar is now the third most important renewable source in the world. We're not talking about a niche market anymore. More than 30 countries already get over a fifth of their energy from these sources. I mean, sites like this, they aren't some futuristic vision anymore. This is a reality across huge parts of the world. And this rapid rollout is boosting energy security, it's helping mitigate climate change, and it's creating real economic benefits. Okay, so this leads to the big question, right? If renewables have all this public support and they're growing at this breakneck pace, why aren't we there yet? What's the holdup? What's the big roadblock? Well, the answer isn't really about making the energy. It's about time. It's this critical, often invisible challenge of energy storage. And it is the single biggest puzzle we need to solve for a world powered by renewables. Here it is. This is the crucial point. Our demand for energy is pretty constant, right? We want the lights on 24/7. But the supply from solar and wind is, well, it's not. The sun goes down, and some days are just calm. This mismatch is called intermittency, and figuring out how to bridge that gap is the key to the whole thing. So how do we store these massive amounts of energy? Right now, the number one technology is surprisingly simple. It's called pumped storage hydro, and it's basically a giant water battery. When there's extra electricity on the grid, say on a really windy day, we use that power to pump water uphill into a big reservoir. Then, when we need that power back, we just release the water, letting it flow back down through a turbine to generate electricity. It's the most important form of large-scale storage we've got. But what if you don't have mountains and reservoirs lying around? Well, there's another path called power to gas. You take that surplus electricity and you run it through water. It's a process called electrolysis, and that splits the water into oxygen and clean hydrogen gas. That hydrogen then becomes a storable fuel, ready to go whenever you need it. You've basically turned electricity into a gas you can keep in a tank and use later. Pretty cool. All right, so we've seen the problem and some of the solutions being used right now. But what about tomorrow? Let's end with a look at an idea that completely rethinks what our most basic infrastructure can even do. Seriously, just take a second to look at this. It might seem like something out of science fiction, but this is the vision of an electrical engineer named Scott Brusaw. It's a solar roadway. What if the very surfaces we drive on every single day could become their own source of clean, renewable power? So how would this even work? Well, it's a modular system. The top layer is this specially engineered, super strong glass that's textured so you get traction. Underneath that, there's a layer of solar cells just soaking up the sunlight. But it gets even better. The panels have heating elements inside to melt snow and ice, and they have LED lights that can change road lines or flash warning signs. It's not just a road, it's a smart, self-maintaining platform. Of course, an idea this revolutionary comes with a revolutionary price tag. The inventor estimates the cost would be around $4.4 million per mile. That is a huge financial barrier, which is why the initial plan is to test this out in smaller areas, like parking lots, to prove it works before we even think about paving our highways. And this all brings us to a really powerful concluding thought from researchers. After looking at all the possibilities for a 100% renewable system, they found that the biggest hurdles, they aren't necessarily the technology or even the long-term cost. The main barriers are social and political. It's about our collective willingness to invest in and adapt to these new systems. So from giant water batteries to roads that make their own power, the ideas are out there. The tech is getting better and cheaper every single year. We have the tools. We can reshape our energy world. So the final question really isn't about engineering. It's about us.